So what happened was we subbed in the point 1 minus a into the formula x squared plus y squared plus 2gx plus 2fy plus c equals 0. We subbed it in, and we got an equation with 3 different letters. We had G, F, and C. Everybody see that? Now, what we said earlier was that when both sides are tangents, it's G squared equals F squared equals C. We quickly replaced the C with G squared. Now, because it's down in this quadrant here, because it's down in the bottom right quadrant, what we said is that G would have to equal minus F, or technically F would equal minus G. They're opposite in sign, aren't they? So this means, what can we replace the 16F with? 16 times minus G, which would be 16G. You cool with that? Going to move it all over one side, and we're going to get G squared equals what? G squared minus, what's it, 14G? Hopefully this works. Plus 14G, thank you. And bring over to 65, and what do we get? What? Minus 65 equals 0. It was plus on the right, and it's on the minus negative now. Oh, at the beginning. Yeah, yes, that's minus. Then when it goes back, it's plus again. All right, 2 numbers that multiply to give you 60. All right, lads. So the mistake was made at the very beginning. I subbed in minus 1 instead of plus 1. So that 2G is positive. Okay, so if we go all the way down, that turns that into an 18G. Because I knew that those factors didn't go in equally, so that was the issue, right? And now it's going to be G. What's a G plus 3 and G plus 15 equals 0. And then after that, G equals minus 3 or G equals. All right. Now, we're going to have to get the F then. What's the F? So if G is, and then F's just the opposite, isn't it? So F will be 15 and what else? 15 and 3, is it? Yeah. Now, lads, 2 ways. I suppose the best way we can go about this is just doing our, and then our C values. What are our C values then? C value is F squared R. So that'll be 9 and 225. And then we're going to have to put them all into the formula here. And we're going to get 2 different answers, aren't we? So the first answer will be, that was a tough question, to be fair to it. What's 2gx, lads? Minus 6x minus 2fy plus 6y. Wait a minute. Oh, good God. Lads. It's 5 and 13, not 13 and 5. I'm on a mare. Sorry, guys. That is 13 and 5. Yeah, that means minus 13 and that means plus 5, and that means 13. And when we square them, 169 and 25. Thanks. Sorry, I should use 5 and 13, not 15 and 3, which is obviously 45, not 65. Okay. Now, what goes here, guys? What? And then here. And then the C value. Oh, no. No. One of them's minus 13, the other one is plus 13. And that is 100 and. Okay, and then the next one. It's where we're using the 5s. Yeah. What's it? Plus 10y and plus 25 equal to 0. Yeah. All right. Now the next one. The next one is handy. handy question the next one was. Right? Sure, the brains were a bit broken at this stage, but you'll see the next question and you're going to say, how did I not even think of doing this? All right. What's the rule when you have a chord and a radius that cuts the chord in half? Perpendicular, which means what? 90-degree triangle. How many of you didn't know that, to be fair? You forgot it. So just Pythagoras theorem wasn't even an option. Like, that's great. Now, for the rest of you who did know it, here's what you're looking at. You want the radius of the circle, don't you? You want that black line I just put in. Now, what's the first thing we can get is we know what the entire yellow line is, don't we? What is it? So what would be half of that? Yeah. So this blue line here will be 2√3. Everybody cool with that? Now, anybody have any ideas how to find this red line here? Yeah. Now, naming no names, but somebody forgot how to do the square on this. Squared, x2 minus x1 squared, right? Yeah. He knew what to do, but he didn't remember the distance formula. Or didn't have his table there. One or the other. All right. And what do we put in? X1 and y1 and then x2 and 2. All right. What do we get here then? 3 minus 1 squared and then, what is it? 2 double minus to make it plus 2. All right. Am I correct saying that's root 20, otherwise known as 2√5? So we have the red line now, don't we? So we have 2√3, and we also have 2√5. And all that's left to find is the radius. So that's 2√3, that's 2√5. This went for 15 marks. And that's your radius right there. What you do now? Practice theorem. Throw it all into the calculator. Use your brackets. What you get? Huh? R squared equals 32, yeah. And square root of 32, otherwise known as 4√2. Okay. That's this one here. Okay. What's the deal? A lot of you knew what to do here, to be fair to you. Okay. What do we do again? Two circles are touching each other externally. What does that mean? What does that mean, lads? Come on. Red line plus blue line equals the distance between the two centers. The distance between the two centers is R1 plus R2. Good. Now, this one, I was hoping everybody was just going to go 10 marks. Thank you very much. Because it is that easy, right? Now, let's work with the HK. This one's in HK method, isn't it? Okay. So, can anybody tell me what is the H value and K value? 7 and? Just 13. 7 and 13. Can anybody tell me the center of this circle then? No. In your tables, it will tell you the center is HK. And in your tables, it will tell you for GF, it's minus G minus F. You only change the symbols for G and F. You do not change it for H and K. It's great that you were making this mistake now and not later. Okay. So what is the center of this circle? Thank you very much. What is the radius of this circle? R squared is 25. Radius is 5. Happy days. That is the HK method done. Okay. Now we're going to go on to the GF method. Why are we going on to the GF method? It's written in GF form, okay? All right, now let's look at this. Are you looking? So we have R1, don't we? R1 is 5. We're after R2 and we're after the center of the circle, okay? So for argument's sake, let's have a look at this one now. Okay, what's G in this one? 2G equals 4G equals 2. 2F, lads, is what? And what's F? What's the center of that circle then? -2 and +1. Are we happy we got both centers now? Okay, now let's find the radius. Is there a radius formula for GF methods? What is it? Okay. And what's the radius there for? Alex, what do I put in here, buddy? -1 squared, yeah. And the C value, you have to go back to the top again. What's the C value? -95. So it's a double minus, which makes it a +95. Then we get 10. Root 10. Oh, sorry, root 100, which is 10. So there we'd be happy that it's a gap of 15 then. That'd be 5, that'll be 10, and the gap in between is 15. What do I need to do next? It's a really tough formula. What you need to do next? The distance between the two centers. You have to prove that the distance between those two centers is in fact 15. Yeah. Now that of all the questions, I thought we had that one in the bag, and we were successfully doing them in class really easy. Thought that one we would have got locked down pretty easily. Anywho, living in hope. All right, so we're gonna do this here. Everybody knows the distance formula. Well, everybody does, bar one. All right. So what do we get next, guys? X1, Y1, and X2, Y2. -2, -7 squared, and then what else? 1 take away 13. Throw all that into the calculator. It's going to kick out root of 225, otherwise known as 15, and long behold, we're on to a winner. All right. Now, this one's a tough one. This is arguably the hardest one in the test. All right, we cool with that? Huh? Only 5 marks. Okay. First of all, can you tell me which one's called S and which one's called C? There's 2 different circles there. One of them's what are the 2 names of these 2 circles according to the question? S is 713, the smaller one, isn't it? And what's C? So C is obviously the larger one, all right? Happy days, all right? So what they're asking is, they're saying there's an infinite number of circles that are what? So S is the smaller one, yeah? And C is the bigger one? So this is S and that's C. Is that correct, Tom? All right, and what's the question say again? It says there's an infinite number of circles which touch C external at the same point that S touches C. So what that basically means is touch C. So we're going to touch C externally. See the big one? So here's what I'm going to do. I'm going to link these in a line. So see this line here? See this line from A to C? Yeah, see that line? I can put any circle I want on this line. Doesn't matter if it's bigger or smaller. Look, here's one. Touches at the same point. Here's another one. See what I'm saying? And what does it do? It touches it at the same point. So the deal is that I can pick any point on this line I want. I can pick any point on that line I want, provided it's outside. So provided, to be safe, I'd go further away than C. Do you get what I'm saying? I'd go further away than C. So I'm going to get the equation of this line. And I'm going to find a point on this line to be the center of my new circle. Yes. You could move it up using the slope if you wanted. What? Did you do it? All right. So let's we have a quick way of doing this. What's the center of this again? That's -2 and 1. And what's this one here? 7 and 13, right? Now, what would be the slope here of interest? Would you say +9 to x and what's the other one? +12 to y. Everybody agrees it's a positive slope. You could use the slope formula, couldn't you? Use the slope formula quite easy. Would everybody agree with 12 over 9, which is 4 over 3? For every 4 blocks you go to the right, You need to go 3 blocks up. Very easy. Do you know what I'm going to do? I'm going to add 4 onto 7. What do I get? 11. I'm going to add, sorry. Give me a sec. It's 4 over 3. So I have to add 4 onto the x value. Sorry, 4 onto the y value. So what's 4 onto the y value? There. And how many onto the x value? 3. So would everybody be happy with the point 10, 10, 7? That's on the same line, isn't it? How do I know it's on the same line? Because it has the same slope. Huh? 10, 17. Sorry, yeah. 10, 17 suit you guys? Okay with that? Now, what do I need to find first? Sorry, this point of intersection, isn't it? That's by fluke, though, wasn't it? No, it's asking for the equation of a such circle, no? Oh, just the center. Oh, there we go. Happy. Any point on this line you want. Any point on that line you want. Okay? And I sort of drew it out, didn't I? That you can just make a circle from anywhere and it'll always touch it all the way up here. See? It'll touch it at the same point. If I could actually make that any larger, it would. There you go. See? Always touches it no matter what. So that's that question. Very difficult question. Right, and we're done.